When we talk about modern applications, the API gateway always comes up as the front door. It's that single entry point for all your clients. But if you're only thinking of it as a door, you're seriously selling it short. So let's dive in, because there is a lot more going on behind that door than you might realize. At its most basic level, the gateway is a shield and a router. It grabs all the requests coming in from the wild internet and figures out which internal microservice to send them to. And that's fantastic, right? It means your clients don't need to know about your backend setup, and your services aren't just out there, exposed.
And that leads us to the really crucial question. It's not just about having a front door. It's about how that door is wired up to all the rooms inside. This connection, the integration pattern, is one of the biggest design choices you'll make, and it affects everything: your performance, your security, even how easy your code is to maintain.
So today, we're going to peel back all the layers of the API gateway. We'll kick things off with the two main ways it can connect to your services. Then we'll look at its job as a security guard, a traffic controller, and finally, how it can become the strategic brain for your whole API ecosystem. Okay, first things first. Let's tackle the most fundamental choice you have to make right out of the gate. How does your gateway actually talk to your backend services? Everything else is built on top of this decision.
It really boils down to two simple analogies, and I think this slide captures it perfectly. You can think of a proxy integration as a transparent pipe. What you put in one end is exactly what comes out the other, totally unchanged. A non-proxy integration, on the other hand, is more like a smart translator. It actually looks at the message, cleans it up, and reshapes it before passing it along.
Let's dig into that proxy model. In this setup, the gateway just wraps up the entire raw HTTP request. I mean everything: the headers, the body, the query strings, and just forwards it. This means your backend code sees it all and has total control. But, and this is a big but, it also means your code has total responsibility for building the full HTTP response from scratch. And that total responsibility thing, well, it leads us to one of the most shared, painful experiences for any web developer. I absolutely love this quote because, let's be honest, who hasn't felt this way before? And your choice of integration directly affects how you deal with this nightmare. And here it is, the error message that has haunted the dreams of countless developers. This is that browser security feature, CORS. Now, in a proxy integration, if you see this, it means one thing. Your backend code forgot to manually add the access control allow origin header to the response. The gateway didn't do it for you because, remember, it's just a dumb transparent pipe. So what's the alternative? Well, that's our smart translator model, the non-proxy integration. Here, the gateway becomes an active player. It uses mapping templates to actually transform the incoming request. It can pick out just the pieces of data your backend needs and pass them along in a nice, clean object. All that HTTP noise, your backend never even has to see it.
And this is where the real power of non-proxy shines. The gateway can become an orchestrator. A client can make one single request, and the gateway can turn around and make calls to 2, maybe 3 different backend services, stitch the results together, and send back one clean response. You can even build entire APIs that talk directly to a database, with literally zero backend compute code. It's incredibly powerful.
So when you put them side by side, the trade-offs become really clear. It's all about where you want the logic to live. Do you want maximum control right in your application code? Go with proxy. Think of it as a delivery driver just dropping off a sealed package. Or do you want to offload all the generic web stuff to the gateway so your backend can focus purely on business logic? That's the non-proxy way. It's like having a fine dining waiter who handles all the messy details for you. Okay, now that we've got the connection sorted, let's build on that. Let's talk about how the gateway becomes your first line of defense, a strategy we call shifting security left. Anytime you talk about API security, you have to talk about the OWASP API Security Top 10. It's the industry Bible for this stuff. And for a long time now, the #1 vulnerability, the big one, has been broken object level authorization, or BOLA. This is the single most common and dangerous threat that APIs face today. So, how does a BOLA attack actually work? Well, it's scary simple. Let's say you log in and ask for your bank statement at an endpoint like /statements/m1001. Now, an attacker logs in with their own valid account, but they just fiddle with the URL and guess your ID instead. If the backend only checks that the attacker is logged in, but doesn't check if they actually own statement M201, it'll just hand over your private data. This is where the gateway steps up as a powerful gatekeeper. You can define a strict contract for your API, like a JSON schema, and tell the gateway to enforce it.
So now, if any request comes in that doesn't match that schema, maybe it has a weird parameter or the wrong data type, the gateway just rejects it on the spot. That malicious request never even gets near your backend code, which not only saves you compute costs, but also massively reduces your attack surface.
Okay, so beyond security, the gateway is also your air traffic control tower. It's responsible for managing the flow of all those requests to make sure your application stays stable and fast, even when it gets slammed with traffic.
And just to give you a sense of the scale we're talking about, look at this number. By default, a single AWS API gateway is configured to handle 10,000 requests every single second. That is an insane amount of traffic, and if you don't have controls in place, it could easily just crush your backend systems.
So the gateway gives you this amazing set of controls. You can set rate limits to stop a single bad actor from flooding your system. You can use throttling to prioritize to say, hey, creating a new order is way more important than just viewing history, so give it more resources. And you can use quotas to cap the total number of calls a client can make over a day or a month. But having all these controls is kind of useless if you can't see what's going on. And a huge mistake people make is just logging everything into one giant pile. The real magic is in tracking specific, granular metrics. Are you seeing a lot of errors? Okay, but are they 401 unauthorized errors? That tells you there's a problem with user tokens. Or are they 403 forbidden errors? That probably means there's a bug in your business logic. Knowing the difference tells you exactly where to start looking. So, when you start to put all these pieces together, the integration patterns, the security, the traffic management, the API gateway really transforms. It stops being just a simple, tactical tool and becomes a strategic control plane for your entire organization.
And this role is only becoming more important. When we look to the future, gateways are becoming the central hub for enforcing standards across all your development teams. They're giving us a single way to manage APIs that might live across different clouds or even on-premise. And now we're even seeing AI tools that help design, test, and secure our APIs right from the gateway.
Which really leaves us with one final thought, one question to ask yourself. Is your API gateway just a simple pass-through, a basic front door? Or are you actually using its full power as a smart translator, a security gatekeeper, and a traffic controller? Is it the true strategic brain of your entire system?